Here's problem number 4 from the Chapter 16 review packet. So we're given a function. Part of the graph is shown below. There's a maximum at m and a point of inflection at n. First they ask us to find the derivative, the first derivative. So 3 times 1/3 is just 1, so I'm left with 1x squared plus 2 times 2 is 4, so 4x minus 5. Exponent is 1, 1 times -5 is -5. So there is my first derivative. Now it says find the x-coordinate of m. So we know here that the tangent line here has a slope of 0, so this is my gradient function. So I want to know, when does this equal 0? So it's really important that you write equals 0, that you complete your equation before you start solving. This one can be factored. X times x is x squared. 5 times 1 is 5, and then I just need to figure out, where do I put the negative? I want more positive, so I'm going to put the positive with the 5 and the negative with the 1, because if I multiply that out, it'll give me that. Then set each of these equal to 0. I get x equals -5 and x equals 1. Now, looking at the position of m, it's got to be this one, because it's to the left of the y-axis. Okay, so there's my x-coordinate of m. Now find the x-coordinate of n. Well, n, they told me, was an inflection point, so I'm going to need the second derivative. So the second derivative helps me get inflection points. So I take my first derivative and I take its derivative. So move the 2 down front, I get 2x and plus 4. Now to find the x-coordinate of n, I need to set this equal to 0. And I get 2x equals -4, divide by 2, x equals -2. So there's the x-coordinate of n. The line L is tangent to the curve of f at 3, 12, which apparently is not on my graph. Find the equation of L in the form y equals ax plus b. Okay, so I have a point, so this is my x and this is my y. I have my x and I have my y. So what am I missing? I'm missing the slope. So if this is tangent to this curve, f, then I can find the slope by using the first derivative. So I'm going to find f prime of 3. What is the slope when x is 3? So I'm going to plug in 3 for my x's into my gradient function, my derivative. That will get me my slope. This is going to get me my slope. In this form here, this is a, it's my m. Okay, so I'm going to simplify this. I get 9 plus 12 minus 5. 9 minus 5 is 4. 4 plus 12 is 16. So my slope is going to be 16. So I'm going to use my y equals mx plus b. I'm not going to use a. I don't care about a. So my y is 12. I found my slope using my gradient function. That's 16. My x is 3 plus b. 3 times 16, that's 48. Subtract 48 from both sides, and I get -36. So now I can write the equation of the line that is tangent. It's going to be y equals 16x minus 36. And there it is.